people are understanding that robot systems don't exist in a vacuum, that our robots, regardless of what they do, are going to have to interact with humans at the end of the day. These advances that we're seeing in computer vision, where we're able to very, very rapidly detect people's facial expressions or people's body posture through things like OpenPose, have enabled our systems to get the data that they need in order to interpret human social behavior. And then on the human-robot interaction side, all of these, we have many studies coming out that are trying to understand how people interact with robots in various ways and how robots can interpret human behavior and use their own social behavior to improve the interactions between human and robot. And so on the production and understanding side, the human-robot interaction research is going to play a big part. My vision for the future is that technology has a positive impact. We have to answer questions about how our technology could be used for good and could be used for bad, and how we can aim our technological advances toward positive impact in the world. I think this really means that we need to be multidisciplinary. We need to pull in lawyers and policymakers and people from social sciences. And we also need to pull in people from technology who understand the capabilities of these systems and understand what's even possible to talk about in terms of the societal impact.
So thanks to Ela for a wonderful talk, and Tom for those great questions to help explore some of these issues in more detail. We're going to shift now into the second session of the conference focused on trust. So I think it's very easy for people to focus on the trust that we might or might not have in the technologies. But one of the important questions is to really go beyond that and to think about the trust that we might have in those who develop the technology, or those who are deploying and using the technology, or those who regulate and write the laws about the technology. Or even more, how technology might change the relationships of trust that we have with one another. So how can the development of a new technology change our human-human interactions, including those that are grounded in this really fundamental notion of trust? So we're going to be exploring that over the next hour and a half and through a variety of formats. And we're going to start with a talk by one of our K&L Gates Presidential Fellows, Abigail Marsh. Abigail was a double major in computer science and mathematics at Oberlin College in Ohio, and is now a PhD student in the Societal Computing program here in the computer science department. Her work really is focused on a notion of usable privacy, the idea of how do we have privacy that is helping us achieve the ends that we want, and in particular how that arises with adolescents and teenagers. So without further ado, Abby.
Thank you so much, and thank you, David, for the welcome that includes my undergraduate education. I really appreciate that. So the funny thing about being a privacy researcher is that when you see a news story about some way that technology or a tech company has violated trust, you actually see through that and you say, oh, this is a privacy violation that these people are really outraged about. Yes, we frame it in the public as trust, but for example, you look at Cambridge Analytica's scandal recently. Facebook has multiple, so let's focus on Cambridge. And you see that what's really being talked about here is the idea that Facebook would allow outside parties to collect information about people who did not consent to it. So they thought that information was private. They thought it was contained within their social networks and Facebook servers, and they had no idea that somebody outside of Facebook could actually be harvesting it and using it for unstated purposes that the user did not get to consent to, right? And you also see other examples of things like this. We talk a lot about algorithmic bias, and one way that privacy researchers study algorithmic bias is through behavioral advertising, online behavioral advertising, where the fundamental question is often, how did this website, this advertising network, which I've never directly interacted with on my own, get this information about me to be able to profile me and sell me these ads, which may be biased in some way. As a woman, maybe I'm more likely to see pregnancy-related ads or mother-related ads. And I didn't even know that the advertising network knew my gender to begin with, right? So these trust violations are actually privacy violations. In my own work, I decided to say, privacy is is a fantastic area of research for technologists, but so far it's really been focused on self-sufficient adults, people in their 20s or 30s or 40s or 50s, and I'm sorry for those of you who've been left out of that, but that is the range that's generally considered worth studying in a lot of privacy research. And there aren't a lot of people who have focused on the fact that people outside of that relatively narrow range of human experience are interacting with technology, sharing their information with these websites and with this software, and therefore can experience privacy violations as well. Many of you in this room will have been parents, or if you aren't parents, at the very least, you were a child at one point. And you probably recognize that the teenage years are very difficult years. It's hard to raise a teenager, especially in today's era where teens are spending a lot of time online or spending time with their devices, right? And so as a parent, it's natural to want some sort of assistance, some sort of help. And there are a lot of software aids that promise to parents, oh, we'll take care of making sure that your child stays out of bad websites or only uses appropriate language or something like that, which seems like a miracle fix, right? You can't be watching your child's phone use over their shoulder every second of the day. So great, install a software and do that. And these softwares offer a lot of benefits, especially for younger children. Maybe we agree that 5-year-olds shouldn't have access to pornography, right? So it's easy to hit just block all porn, and your 5-year-old can use your iPad without any danger of a weird Google result, sort of like prompting that birds and the bees discussion a little too early. But it runs into a lot of issues when we talk about teens and preteens who are doing a lot of their socialization and identity formation online, right? They're talking to their friends, they're figuring out who they are, and some of that might mean exploring concepts and topics that are occasionally inappropriate and in general might be inappropriate, but are necessary and important in certain contexts, right? And there's a lot of trust violations that these softwares can pose. As a child, why would I want a software like this on my phone? How do I know it's going to respect my autonomy? It's essentially designed to snitch on everything I've ever done wrong and send an alert directly to my parent at the moment of violation that, like, hey, something is going wrong here, you should go punish your child, right? And even if we don't consider the child's feelings, there's still the parent's concerns about trust, right? These softwares can collect a lot of information about what the kid is doing with their phone. Some of them suggest collecting every text message, the contents of every text message that your child sends, or every social media message, right? That means text and pictures. I don't necessarily want a company to have that data about me or about my child. And these are concerns that parents have to face when they choose to install a software like this on their child's device, right? We don't like when Google or Facebook has this information, but we're supposed to be okay with it when a much smaller, less accountable company does. And finally, there are questions of algorithmic biases. A lot of these softwares use ML to do something like predictive blocking of content within web pages, but how do I know as a parent that this opaque algorithm is respecting my parenting wishes, is blocking what it should be, and is not blocking what it shouldn't be? So there are a lot of trust issues here with technology that involve people other than self-sufficient, sort of middle-range adults who are willingly interacting with the software in question. And we need to continue to ask questions about who is using this and who is being affected, so we make sure to capture the experiences and the privacy needs of everybody in our society.
Thank you so much, Abby. Really wonderful, and it's always wonderful to see the amazing research that's being done by the students here, that it isn't simply faculty, it's the graduate students, it's the undergraduates, it's the many people around this community all engaged in asking these kinds of questions. So for the next part of the session, we're going to try something a little bit different, and hopefully it will go smoothly. So we're going to ask 3 of our distinguished guests to join us up here, and perhaps turn the tables a little bit, have them not simply be speakers, but also be moderators. So what we're calling it a long conversation, and the idea is that we will sequentially interview one another for a brief period of time, about 5 minutes, at which point there will be a very discreet chime to let everyone know that we're going to move on, and the next part of the interview will happen, and then we'll have a much broader conversation among the four of us around issues of trust. So I'm delighted to invite up three people. Kerstin Vignard is an expert in international security policy with over 20 years of experience at the United Nations. She's currently the Deputy Director and Chief of Operations at the UN Institute for Disarmament Research, UNIDIR. And since 2013, she's led UNIDIR's work on the weaponization of increasingly autonomous technologies. That sentence came out wrong. She's led the work on trying to understand the impacts and how we might address the weaponization. She has not been weaponizing technology herself. She also has served as a consultant to 4 of the 5 UN groups of governmental experts on cybersecurity. Moshe Vardi is the George Distinguished Service Professor in Computational Engineering and Director of the Ken Kennedy Institute for Information Technology at Rice University. He's a world leader on automated reasoning and is the author and co-author of over 500 papers, as well as 2 books. He's received numerous awards and honorary degrees and is a member of 5 different national academies, including the U.S. National Academy of Engineering and the U.S. National Academy of Sciences. Finally, Manuela Veloso is the Herbert A. Simon University Professor and head of the Machine Learning Department here at Carnegie Mellon University. She's transformed our understanding of social and collaborative robotics and has also authored over 500 papers. She was named the Einstein Chair Professor by the Chinese Academy of Sciences in 2012, is a fellow of the American Association for the Advancement of Science, as well as the IEEE and AAAI, and is a former president of the AAAI. So, Kerstin, Moshe, and Manuela, if you could join me up here on stage. Microphone there. Moshe and Manuela, their microphones. Yeah, great. So we'll start with Kerstin. In your view, what is the most important or challenging aspect for trust in AI and robotic technologies, including their development and use? A nice, simple question.
With only one answer.
With only one answer, only one possible answer.
All right, well, I'm coming to this conversation from an international security and arms control perspective. So I guess you won't be surprised when I say that I find the implications of the weaponization of these technologies to be a particularly important topic. Issues surrounding transparency, validation, and verification of algorithmic systems are among the most important open questions in AI today, and they are equally important from an arms control perspective when we start considering the implications of increasing autonomy in weapon systems. So I'm going to give you 3 examples of how trust in these systems is challenged by developments in AI. So first, we have challenges for testing and verification of weapon systems. And it's probably pretty obvious, but you really want to trust your weapon systems. These are technologies that are intentionally designed to do harm, right? Unlike many of the technologies that we design. And because of that, as operators of these systems, you have a moral and legal responsibilities probably at a higher level than you would have as an operator of a different type of technology that's not designed to cause harm. And one of the reasons that we trust our weapon systems is because we rigorously test them before deployment. And this isn't an aspiration, it's actually a legal requirement under Article 36 of the Additional Protocol 1 to the Geneva Conventions. So increasing autonomy in weapon systems challenges testing due in large part to issues of predictability. And it's further complicated in the case of learning systems where the system continues to learn post-deployment. And then verification, which is a very important concept in arms control. We use it as a stability mechanism, verification. So how could international regulation of military applications of AI be verified? Verification usually involves counting physical objects, right? So intangible capabilities don't really work that way. And it's difficult to imagine that states or even corporations would be willing to permit inspection of their code or algorithms And it's questionable that even inspection would even be useful because determining whether or not an algorithm is quote unquote militarized is probably near impossible, right? Because it's a dual use sort of situation. Second example would be trust by the user. So machine learning systems sometimes behave unexpectedly or in unanticipated ways. And in many cases, having AI help us solve problems in previously unimagined creative ways is what we want, right? That's a benefit of AI. But as we become accustomed to AI-enabled objects behaving in surprising ways, we're going to have one less metric to determine whether a weapon system is behaving in a way other than the way the operator intended. So that could be due to internal error, or it could be due to malicious intervention within the system, and that's going to diminish the operator's ability to intervene or exercise control. And as military systems become increasingly autonomous and concurrently humans become decreasingly present in their operation and oversight, there's a risk that humans no longer serve as the redundant safety feature, which they currently serve in many weapon systems. I mean, I think we all know about the many nuclear near misses that have been avoided because a human operator followed their instincts rather than what the technology was telling them was happening. So if a human's no longer capable of intervening, oh my.
Well done.
Can I finish up that sentence?
You can certainly finish the sentence.
All right. If they're no longer capable of intervening due to speed or in your ability to understand the system, or perhaps even worse, we've left the human on the loop marginally just in order to serve as a scapegoat for technology's possible failings or shortcomings, and that's problematic. So those are two examples, and maybe I'll get a chance to tell you a third.
I'm sure there will be opportunities, so. If you would like. Yeah.
Good to see you, Moshe. In your view, what is the most important or challenging aspect for trust in AI and robotic technologies, including in their development and use?
So, I think it's important to recognize that we are in a situation right now that we have, I would say, a trust crisis. And I want to read quotes from two recent articles appearing both in fact, in the Wall Street Journal. Just Peggy Noonan, last October, article somehow talked about the gun issue, and she tried to explain why people buy guns. And the argument, I think, is very weak, but it doesn't matter for the purpose of this discussion. And she writes, because all of their personal and financial information got hacked in the latest breach, because our country's real overloads are in Silicon Valley and appear to be moral Martians who operate on some weird new postmodern ethical wavelengths, I guess with financial planning for immortality. And they will be the ones programming the robots that will soon take all the jobs. January of this year, Neil Ferguson. Most alarming was the morphing of cyberspace into Siberia, not to mention the cyber caliphates, a dark and lawless realm where malevolent actors ranging from Russian trolls to pro-ISIS Twitter users could work with impunity to subvert the institutional foundation of democracy. If this does not reflect a crisis in trust, I don't know what is. So if we want to talk about trust, we have to start by thinking, what does trust mean? So I kind of try to reflect a little bit on my own personal experience. In my military service in the Israeli Defense Forces, I went to parachuting training. And you jump from a height of about 1,400 feet, which is a rather terrifying experience. I mean, your back brain tells you you're going to die because you're falling off the cliff. And you have to trust the parachute, and you have to trust the parachute folded it properly. So trust means vulnerability. You need trust when you have a sense of danger and you're trusting something or someone to help you face this danger. And so obviously, if we have a crisis of trust, it means we're all feeling very vulnerable. And do we trust the technology that is now providing us? So I think when it comes to cybersecurity, there's no cybersecurity, there's cyber insecurity. It's a colossal failure of us as a computing discipline, as well as I think as a political institution around us, that we have not set up better standards for cybersecurity. And now we are talking about, do we trust that the decisions the machine will make? And we hear a lot about equity and biases and transparency. And I have heard very little discussion, should we delegate this decision to machines? You know, we are somehow as if we are living in a deterministic universe in which it's just determined the machines will make these human decisions. You know, now it's just deciding, you know, whether you'll get parole or not, whether we'll separate a child from their family. When is it going to be decided who's going to be your mate? You know, we already have algorithmic. Why bother with Tinder? You know, we'll let the machine decide whom you should go out with. And so, and the reality is that people don't like to talk so much here, is that our life now with technology is being run by incredibly large and powerful corporations. Total equity of the 5 tech companies over $3 trillion. And one of the things we've heard before, there's no ethics when it comes to corporations. If it's legal, they can do it. And if it makes money, they will do it. Manuela, we seem to be on this panel quite a lot, right? Exactly. In your view, what is the most important or challenging aspect for trust in AI and robotic technology, including their development and use?
So I have a more engineering view of this trust question, and more kind of like I've been questioning how can we do it better at really the development level. So we all want to trust these machines, but eventually we have to interact with our PhD students, with our students to do PhD thesis, to advance the science of artificial intelligence and robotics. So how is my dialogue with those students? How is my line of research? How is like the steps that we take to advance our science going to be different? Because in fact, we care about trust. So my few remarks are really bringing you down to not the army, not the weapons, but to the moment in which you face a computer and you have to type if this, then that, and you have to program these machines. And you have to help build programs for which eventually there will be a change in society. So along those lines, for me, this question of trust has to do with the fact that our AI machinery, our machine learning, our robotics machinery, has been more of a problem solver. So what's the shortest path? And we generate a solution. But the way that we actually function when writing code, when writing programs, when writing algorithms, is that we don't have the challenge of justifying or explaining why did you say this was a bottle? Why do you classify this as a chair? So the explanation part has been was present in the old days, I mean, and it has been always kind of underlying their research. We even have theses on explanation-based learning, when we have theses on all sorts of like analogy, trying to come up with like the similarity between two problems and justify that resemblance to make adaptations. So, but it's not as present now in terms of actually solving big problems and still also being able to justify, if needed, and have our algorithms generate such justifications. So my research and my understanding of trust leads me to, for example, have our autonomous robots who actually navigate in our environments arrive to your office and be able to answer in language and not in whatever language they use internally of numbers and probability and all sorts of like functions in language. Why are you late? And why did you take that route? And what are you going to do next? So I believe that trust comes from the interaction with the device, with the machine, and eventually that machine needs to be able to be queried, needs to be able to be questioned about the decisions that actually they made towards solving whatever problem we ask them to solve. So in that sense, for me, trust has to do a lot with transparency, with explanation, with counterfactuals. Can we ask a machine, what if you had done something different? Can this machine process these type of questions and be more explicit about whatever algorithm they're running and what the solution would be on those scenarios? So transparency and explanation, I think, are part of the internals of AI machines that may enable us to build more trust in what they do.
Thanks to all three of you. Really got some wonderful issues out on the table. And so I actually would like to start, Manuela, if it's okay with you, with what you were just talking about in terms of the transparency and explainability. And I think one question that comes up when we think about the trust is perhaps transparency for whom or explainability for whom? Because, of course, something that would be understandable or explainable to a PhD graduate student might be very different from somebody on the street who doesn't know as much about the technology. So how do we think about these different audiences for explainability?
It's a very good question. Not only the different audiences, but also different moments in time. Even for someone that interacts with the robot or with the agent many times, you don't want to produce the same explanation today that you produced yesterday, or otherwise it's just, you are telling me the same thing, and that didn't help me. So we actually introduced this concept of a space of explanations, a space of verbalization, together with one of my students, Said Salvaraj, and Vittorio Pereira, and Stephanie Rosenthal, and we have been working on this issue about the multiple facets of explanations. And in fact, trust, these levels of trust, these levels of transparency, this level of explanation are not a single entity, like you say, a single kind of like concept. And we have done some machine learning on crowdsourcing people and trying to understand if someone asks, what exactly do you do happen by the elevator? That exactly by the elevator would be something that would require a much more narrow explanation, as if someone would ask, where do you come from? And that's like a language that requires a different explanation of the mobility of the machine than what happened by the elevator. So we did a lot of research, and we do, as we speak, a lot of research on trying to understand a question from a human, what exactly means in terms of an explanation required from the machine.
So it seems to me that in a lot of cases, this kind of explainability, if we had it, would be able to help some with one of the issues that you raised, Kerstin, which was about the difficulty of verification in rapidly changing environments where the system might be deployed somewhere, whether on the battlefield or in an international context, where perhaps it hasn't been used before. So how do we verify that it's going to work there? Do you think that explainability would be something that could provide a guide as we think about sort of how to, how we can build trust in, as you said, some of these technologies that can even have lethal impacts?
Well, you used a great word, transparency, and that's something that we talk again a lot about in arms control as a stabilizing element. So yes, I think explainability is extraordinarily important. At the same time, it circles back to that question of for who are we explaining to, and when? Because when we're talking about lethal systems, sometimes post facto explainability, it's good to be able to unpack that, right, afterwards if something went wrong, but it's a bit late, right? So explainability is very important, but I think we should be focusing more on thinking about how do we ensure confidence in the systems, whether they are weapon systems or other systems, before we deploy them. And so explainability, I think, is a much earlier part of the process than actually post-deployment. I mean, it's still necessary, and it's part of that very important human-machine interface that's going to be critical in all of our AI embedded systems. But explainability with weapon systems, because of the risk being so high, it's, I think, it's a bit of a unicorn. We need it a lot sooner, right?
Certainly, as you said, the post-fact, that is small comfort if
Exactly.
after the fact you know why that happened. And it seems that in many ways that connects to some of the things you were raising, Moshe, in terms of the need to be able to trust the developers themselves. Right? We can trust Manuela's graduate students. We can trust Manuela. But as we've been hearing about in various times throughout this conference, there are companies who are doing things that perhaps are not out of an effort to produce technology that will help people as opposed to helping the bottom line. So could we extend, for example, this notion of explainability to the developers? They have to explain why they did what they did. Or what solutions do you think we might, or paths might we be able to go down to improve trust in developers?
Well, I think we have to go back to the question, why do we need trust? And we need trust because we feel vulnerable, okay? And this is basically human fear. If you're a child, I remember being a child and walking in the darkness. And why are you afraid when it's dark? Well, because you don't know what are the threats out there, right? I mean, so you turn the light on and say, okay, there's nothing here to worry about. And so human beings are very vulnerable. We're very fragile, okay? And so if you think about all these things that we're talking about, transparency and explainability, are all essentially a way to assuage us, that we don't need to be afraid. So this is really, we need to go back. The issue in some sense is not so much about trust. The issue is about vulnerability and fear. And unfortunately, what we've been learning the more you learn that your fears are rational, they're really, just because you're paranoid, it doesn't mean that someone is not trying to kill you. And what we've been learning recently, there are people out there for us. Maybe not to kill us, but to manipulate us. And this, if you think about this issue being manipulated, it goes back to our sense of self and vulnerability, and we feel violated when we realize we've been manipulated. And so maybe it's not a threat for life, but it is still some kind of a threat to our own notion of self and self-determinacy. And so we have to figure out, the issue, first of all, is not how to somehow make us feel safer. First of all, there have to be real safety. Then we deal with the psychological factor, okay? Right now, unfortunately, we are missing the regulatory framework that will make this technological world really safe. And that's why we are afraid. That's why we have no trust in the system. So we have to go beyond just focusing on the trust, assume that it's a safe world, and your feeling of fearfulness are not justified. Right now, I have to say, I think they are justified. So we have to go beyond the trust issue. We have to remove the threat first. And then we have to deal, how do we make sure that people really trust that this is a safe environment?
So Manuela, would you want to switch to becoming a social scientist and policymaker to remove some of these threats?
I'm going to wave my hands about things that don't work. But so I actually tend to disagree with this.
We always disagree, it's okay. That's why they put us on a panel together, otherwise it will be boring.
So, besides the fact of being safe and afraid, you also want to trust a machine that if you ask, find me a flight to Paris tomorrow, or get me a good flight to Lisbon, that actually it does the job. So it's just trusting the fact that the thing is going to do what you expected it to do. Or if you had like a robot around here that you'd say, go to the conference room and guide the visitor back to my office, that's the case, that the robot does not go to the kitchen or does not go anywhere else. So, or my refrigerator, if I put something in the freezer, I expect it to actually freeze the food. So there is something about technology that, for me, the trust is that in some sense also, it does what it's expected to do. And I think that before the actual solving my vulnerability, there is also the need to meet the expectation, meet the specification. And in AI, we are still not there because we really don't have like robust robots that we say, go down this road and don't go over anyone. We are still trying to find the machinery that matches the specification at what we would like the autonomous agent, the autonomous robot, the autonomous AI assistant to do. If I am a doctor and I have an AI assistant that I would like to say, go and see if you find any case similar to this on all the images you have, collected all these data from all over the world, I would like to trust that the thing that I'm talking with, this AI assistant, does in fact go through all the data in the whole world and not just to parts of it to actually answer my question. So what I believe is happening, what I believe, for me, trust is that the task that I will interact with this AI agent to be performed is actually done the way I expected it to be done. So that kind of like matching my expectations when I interact with the AI agent is where I believe that I build a trust in the machine. I want to add one thing, though, to the point that this trusting the developers. Do not trust me, do not trust my students, and I'll explain why. It's not trusting, but when just one single thing. I'm not going to put my hands on fire and guarantee that my robot is not going to hit the wall, or I just have a hard time achieving that level of assurance. And the reason is because the world, the environment, the people are very complex systems. It's extremely complex to, from a research point of view, develop a solution that is trustable for the complexity of where we want to make our systems autonomous. It's not bad faith. It's not like, it's not really intention. It's just that it is too complex. It's just too hard. And it's too hard in the sense that there is a very uncertain system that you now are supposed to handle with some kind of like algorithm. So it's like the Sandy Storm. It's like 9/11. It's like all these complex things that no one was able, even within humans, to be able to find a solution for them. They just, I mean, the world is too difficult. It's too hard. On the other hand, are we going to give up on automating things just because of the complexity? And so what I'm trying to tell you is like this. I believe we have to accept that AI, as humans do, will eventually make mistakes. What we might not want to accept is that it doesn't improve over time. What we might not want to accept is the lack of learning. What I'm saying is that any kind of instance of something that didn't go well needs to be more data, needs to be more input for the AI system in its dynamics, like Ila was saying, to become better. Even whatever cognitive assistant you do to a person, if it's not a moving system, a dynamic system that gets better with experience, we are not going to ever be able to, I believe, generate some kind of static system that handles this enormous complexity. And just to finish one thought, I've been doing robot soccer for 20 years. So little soccer playing robots that go to these competitions. Even after 20 years, there is always something that surprises us in these games with an opponent. Robot soccer. There is the adversary just shoots and bounces off one of our robots, and we say, how come? You are supposed to shoot directly at the goal, not use our robots at bouncing halls. Yeah, that's what happened 2 years ago. Then last year, another one of these surprises. Inevitably, even after 20 years. Can you imagine that I go to these games and I'm still surprised how these adversaries figure out something that I did not thought about? So that puts you in this kind of learning curve, in this kind of like trying to minimize the errors you make and not really assuring that there are no errors. It's just very hard,
well,
unfortunately.
And of course, perfect predictability and trust. You don't have to have perfect predictability to have trust. We could have, for example, many of us have trust in other humans, even though humans surprise each other all the time. It's, I think, does go to this issue that Moshe is saying of we're making ourselves vulnerable in certain ways, and trust is relying on somebody else when you're in that state of vulnerability. And I think it raises all kinds of interesting questions, of course, about the weapons space, because is it reasonable, we've got very good reasons to think they won't be perfect. They will make mistakes. Of course, human soldiers make mistakes. Human policymakers make mistakes. So when we think about verification, we think about deliberation about what we as an international community or a national defense organization ought to do, how do we think about the necessity of accidents, the necessity of surprises? They're going to happen. Is it, do we aspire to too much if we aspire to, we know we aspire to too much if we aspire to perfection? Do you have thoughts about the relevance of accidents and surprises in the context of weapons? Feel free to say you'd like to pass.
Actually, no, we have a whole paper on this. But I kind of wanted to pick up on something my mother was talking about.
Sure.
Do you mind?
Please.
You were talking about expectations. And this is a really, probably quite technologically sophisticated audience, technologically literate, but I deal with a lot of people who don't have a lot of technological literacy. I think we're at a real interesting tipping point when it comes to this issue of trust in technology right now, where a lot of people have blind trust. We have fear, but we have blind trust in technology. And recent events, pick one, because there's many to choose from, have, I think, brought us to a societal conversation about, wait a minute, we have to go from having blind trust to having our technologies, the developers of those technologies, and the users and the deployers of those technologies, they need to earn my trust. And we're going to have to make that tipping point between blind trust and earning trust. And what are the mechanisms and what are the tools that we have to earn trust, to verify trust, to have reliable systems, predictable systems, confidence in our systems? Isn't that much more interesting than weapons?
It is, yeah.
I think that's a very good point about this earning trust. And in fact, one of the things that we are working on now is like to have these robots actually what we call verifiable answers. So if I ask a robot, how long did it take you to go from the lab to my office? And the robot says, 2 minutes and a half. How do we know that number is right? And so what we do is that we actually have techniques to decompose that question and to say, okay, how much did it take you from going to the lab to the kitchen? And the robot would say, 1 minute and 10 seconds. And now we ask from the kitchen to my office. And if these add up to 2 minutes and 30 seconds, then you trust that the answer was good. So we are doing a lot of research with Vittorio Pereira in his PhD thesis on this kind of like earning the trust, on finding methods to decompose your questions so that if there was some malware or some wrong answer, that you cannot, from a theoretical point of view, randomly combine so much error, so much malware that eventually things become consistent. So we are trying to earn trust not only by explainability, but by checking consistency of the answers, such that they actually add up to something that makes sense. And after all, they are computing or they are answering something that overall makes sense, and it's proved to be right. And so that's something that's very new in our research. I mean, we barely have started this, but again, this is the question of like, when they give you an answer, do you trust it or not? So you transform that, it's like saying, oh, if it's giving me this answer, okay, then I'm going to trick it and ask 10 more questions until I'm confident that I earned that, that this thing is trustable. So,
well,
it's, yeah.
And I think that this is, I'll just put in a quick plug, I think that this is one of those places where interdisciplinary work, multidisciplinary work becomes really critical, because this idea of earning trust, development of trust, that's an area that social psychologists, organizational behavior theorists have studied for a long time. And so there's a lot of resources that can be sort of bootstrapped to maybe short circuit some of these things. But Moshe, I'm sorry.
We talk a lot about trust in technology, But the reality is trust is mostly a human relationship. So if I'm talking about the robots that will come out of Manuela's lab and I say, I trust that robot, I really trust Manuela to make best efforts to give me something which is going to be safe. So, because I really, most of the time, for most people, the technology is kind of a black box. So what does it mean that I trust this program? I have to trust the developer of this program. So we really need to think about the different actors that are involved here. And to think of trust as a relationship, it's a human relationship between different actors. Do I trust Manuela? Yes. Do I trust certain corporations?
No.
Maybe no. Okay. Do I trust a developer that I know nothing about? Partly it's the same thing. When we feel safe with people we know because we build trust between them. You walk into a place where you don't know anyone, and in certain areas of the world, still every stranger is a potential risk. And so we have to start thinking less about the technology and more about who are the set of characters in display and what are the set of trust that we can have between them. And one of the things, of course, we know in a warfare situation, it's a different situation, and we have to think very differently about trust than we think in a non-hostile situation. But I think the trust, ultimately, it's not a relation between human and machine. It's a relationship between humans.
I disagree.
Well,
Machines will be like humans. They will make decisions, they will process information, they will have tons of data, and they will be things you interact with like you interact with humans. So eventually you may want to also trust the machinery and not just the humans who develop the machinery.
I don't disagree, but if I trust my refrigerator, it's because I really trust ultimately the process that led to building this. I mean, how does the refrigerator earn my trust?
Yeah.
One, because it does what it's supposed to do, but I don't think there's anything nefarious about it that really the goal is at some point to suddenly surprise me and give me poison food because, the people who built, I trust them ultimately. So we end up trusting machines by their predictability. If something is predictable behave in a certain way, we say, okay. But also, we intuitively think about the actors, the human actors involved in this.
Which, of course, then raises a whole other set of issues and complexities around when you have companies doing this that for good competitive reasons are not going to disclose how they built the technology, are not going to, how do we get transparency of that sort? And I think these raise an enormous number of questions, and unfortunately, I'm getting the red light that tells us that our conversation is coming to a close. I wanted to give you each 1 minute if you want to say something very quickly, sort of in closing. Manuela?
So I just want to say one thing. I saw recently a very interesting video in New York in which people were interviewed on the streets about these things we kind of mark. I accept all those terms of conditions of iPhones and Facebooks and all of this. And they were horrible, the things we accept. And I was looking at that, and say, guess what? It was a lawyer, it was a human who generated that thing and not an AI system. Imagine if that text were generated by a robot or an AI system, which was fooling me into accepting all sorts of horrible things that we accept. We never read that pages and pages and pages. And whoever generated that was not an AI system, was a human. So shame on the humans in the sense that that's where, I go back now to what Moshe was saying, but let's educate the humans. Let's eventually have the humans make these things we accept on in terms of machinery be trusted. Because this Facebook example, yes, we didn't accept. But how did you know that in the whole thing that you signed up for, you were not accepting that these data would go somewhere else? I mean, I have no clue. We just accept. So humans in the loop of technology need to make sure that things are trustable. And humans need to make sure that that is the case. I'm sorry for my K&L friends, David, I'm sorry. But that's really intimidating, the things we accept in these terms and conditions. It's like, oh my God, what am I signing for? And somehow it's still not generated by an AI system.
Right.
And I wonder if it were an AI system generating those conditions, if people would not be all outraged. How come an AI system told me to accept all these conditions? I'm telling you.
Trust in technology rather than humans. Moshe, any final thought?
I think that we really need to think very hard about what makes corporations behave unethically. And it's not the people in them. I mean, some of the people here from corporation, as we I spent a big part of my life in a corporation, many of my friends are in corporation, but nevertheless, there is something, our current economic system, that makes corporations behave legally and unethically. And that means either we need to change the laws to make more behaviors illegal, or we need to rethink the incentive system under which they operate. Because they are just, right now, in this part of our history, so immensely powerful that their behavior has huge impact on our lives.
Kerstin, any last?
Yeah, just sometimes I think we get caught up in the bright and shiny and the possibilities and the potentials of new technologies, and we forget that these technologies serve us, right? And so rather than it starting always as a technology-centric conversation, which is not only constantly evolving due to innovation, but also quite alienating for a large part of the population who doesn't have the technological sophistication to participate in some of the more deeper conversations about it. We need to be having more human-centric conversations about how humans employ technology to meet human objectives. Unfortunately, in my field, that's human objectives of conflict and resolving. These are the tools of violence that humans decide to employ. But in other fields, whether it's healthcare, education, or criminal justice, these are tools that work for us. And we need to affirm our human values and our objectives and our desires and what levels of trust we're going to demand or what metrics we're going to use, and then ensure that our deployers and our developers of technologies meet those requirements, because we're in charge. At least for now.
At least for now.
Nominally.
So with that call to action, let's thank our wonderful panelists, conversationalists. Thank you. Yeah. So we're now going to shift to one last part of our session, which is, yes, please leave the microphones, sorry. They'll get back up there eventually, which is a final spotlight talk by Professor Anka Dragan, who is an assistant professor in electrical engineering and computer science at UC Berkeley, and I believe, proud, at least an alumna, got her PhD from here at Carnegie Mellon, and I think is proud of that fact, I hope. And she, at Berkeley, runs the Interactive Autonomy and Collaborative Technologies, or Interact Lab, which is really focused on a lot of these questions about human-robot interaction. How do we have robots that actually are able to interact with humans in ways that can support and empower both sides, which requires doing research really at the intersections of robotics, machine learning, and cognitive science. She's also helped to found the Berkeley AI Research Lab, is a co-PI of the Center for Human-Compatible AI, and has won multiple early career awards, and we're delighted to welcome her back to Pittsburgh. Anka Dragan.
Hi, everyone. Pleasure to be here. I am going to basically agree with everything that Manuela said and maybe add one twist. So robots take actions that change the state of the world. And as we've heard yesterday, the way they choose the actions to take is usually via something called the reward function or objective function. So they plan actions that, in expectation, maximize cumulative reward. And I think when things can go wrong is when people have mental models of these robots that do not match up with reality. And so that, for instance, the robot is much less capable than what the person assumes, or it doesn't take the actions that the person thinks that the robot will take. And so I've been asked to talk about trust, but what I really want to talk about is not so much how do we get people to trust these systems, but rather how do we ensure alignment between the person's mental model and reality. And I think that there's two complementary ways to talk about doing that. On the one hand, we can work on the robot side and try to bring the robot up to match, to live up to our expectations. And I would call that making it trustable or trustworthy. On the other hand, we could work on the human side and bring expectations and calibrate them, right, to reality. My background, my personal background, is actually in transparency. I don't want to focus so much on transparency today, but I do want to talk about it for a couple minutes to just share some highlights. So if we talk about robots being transparent, we have to actually define what that means. And I'm going to propose one definition, which is what I've been using. I don't think it's the only definition, but the way I've been thinking about the problem is that there's some internal state to the robot, like its capability, its utility, its what it plans on doing. And the human doesn't get to know that. But what the human can have is some sort of estimate or belief in what that is. And as the robot takes actions in the world, and these actions could be physical actions or explanations, that ends up changing the person's estimate. The person gets to observe that and adjust their mental model over time. And so I believe that we have an opportunity here for the robot to not just maximize the reward it's been given to achieve the functional task, but also reason about how its actions are affecting the person's belief and try to come up with actions that steer the person's belief towards the correct mental model, towards reality. And that, to me, is what transparency means. And before I move on, I just want to give you a few examples of what that might look like. So here's a robot that is planning to grab one of these two bottles, the one on the right, and it could do it pretty efficiently, but then it'd be kind of confusing to a person observing which bottle the robot is going for. So what this robot is figuring out is that by exaggerating its motion to the right, it can become more clear to a person observing this motion what it is that it's about to do. It's not the most efficient way, but it's a way that increases transparency by carefully selecting actions that take the person's belief towards the object on the right, the correct goal. That was my thesis at Carnegie Mellon here. We call this legible motion. In the meantime, we've generalized this to a few things. So utilities, for instance, here's an autonomous car, sort of placing a passenger in a situation and showing, in this situation, I would cut this other guy off to convey to the passenger that, look, my driving style is a little bit more on the aggressive side. I do believe we have to calibrate expectations about capability a lot. And so, because people tend to overassume. So what we've been working on is also these robots that fail and show you the failures and show them expressively. So a robot that says, here's what I'm trying to do, and it's not working, and here's why it's not working. I'm trying to pull on this thing, but it's locked. I'm trying to push this thing, but I can't do it. I'm trying to lift this cup, but it's too heavy. And then the final example is one of an agent that plays Pong, trained via deep reinforcement learning, which is all the rage these days. What the agent is doing here is it's showing us how it would act in states that it thinks are critical, meaning states where it thinks it's really important to take the action that it's about to take. So for Pong, this means when the ball is coming close to you and it's at a high speed, then it's really important to move that pellet up or down. And so the agent is showing you this so that you can build this mental model of what it is that it actually has learned. So in a nutshell, we can enable transparency by being careful about steering the person's belief in the right direction. But after working on transparency for a bit, I became a little bit disappointed with it. Because what transparency is about is calibrating the person's expectation. It's all working on the person. And wouldn't it be nice if we could do some work on the robot side to get the robot to live up to the person's expectation, as opposed to just bring the person's expectations down? In a lot of ways, this is what artificial intelligence is all about. Most of the work in AI is about making robots more trustworthy, making robots actually more capable of doing the thing. Typically, that means getting robots to solve this optimization problem. How do you actually optimize the reward that it's been given to you? But what I've been finding is that even though this is one modality of increasing capability, there's another thing that can go wrong, which is the reward function itself. So sometimes the reward function does not actually correspond to what we actually want the robot to be optimizing for. And it makes sense, because the people who are building these robots, we're human too, right? And we're fallible, and we don't always encode the right objectives or incentives in the robot. Here's a cute example of this going wrong. This is a video from OpenAI, and this is a boat racing agent. You can't tell that it's trying to race by looking at it. The reason is that the reward function was score points in the game. And so while on the top left there you see all the other agents actually completing the race, what our boat does is it figures out this loop that it can do and time it just right so that it collects all these turbo boosters at the right time and get a gazillion points. Okay? So you look at this as a designer, they're like, oh my God, of course this is not what I wanted. Of course I wanted you to actually participate in the race and try to win, but that's not what was specified. This is not a new problem. Stuart Russell and Peter Norvig give this example in their AI book of a vacuum cleaning robot. And the reward function could be the amount of dust you manage to suck in. And that kind of makes sense, because the more dust it sucks in, the cleaner the floor is. But then, depending on the hardware, the optimal policy can be suck in a little bit of dust and then dump it all out. Then suck in a little bit more, dump it all back out, right? And recycle that. I don't think this is necessarily that specific to AI. I think this is kind of a general problem with technology as a whole, and I think it comes from something that we all know about, which is that we're not very good at saying what we want, right? We have all these myths and legends about be careful what you wish for, and the reason you should be careful is because you might just get it and you might not be happy with the consequences, like Kim Midas wishing that everything he touched turned to gold. And I do want to emphasize that this is not a story about that is only applicable to agents that actually are capable at optimizing their objectives. I struggle with this every day. I do a lot of motion planning work. In motion planning, you have to write down a cost function that trades off between different things that are important to the robot. In this case, distance to the person, distance to fragile objects, and so on. What inevitably happens is you tune the thing, it works over 10, 20 different problem settings, different environments. And then you encounter a new environment at some point that's different enough, and the optimal behavior does not actually correspond to what you actually wanted. So overall, we're not great at specifying these reward functions. And I do want to make, because this is an AI and ethics conference, I do want to make a little bit of a theoretical point on ethics, which is that I think that makes it difficult to encode the ethical principles that we as humans find so easy and common sense into these machines. And I'll use Mickey as my helper to make this point. So Mickey Mouse, this is from Fantasia. Mickey Mouse was charged with getting water from outside the house into the home. And Mickey gets tired of this and makes a robot, right? Uses magic to bring a broom to life and shows it how to do the task. Then Mickey goes to bed. And then Mickey wakes up and he's in a puddle of water. And he realizes that his robot assistant was a bit overzealous with optimizing the objective function that he specified. What's interesting here is that Mickey then goes, and you'll see in a second, he goes and tries to stop the broom. But that doesn't work because the broom was given an objective function, and sort of what Mickey is suggesting is not optimal. And so kind of a very, very basic, I'm not sure I would even call it ethical, basic principle you might want to encode, right, in this reward function is, look, you should do what people say, okay? So I just want to point out that on a theoretical level that that's not actually that trivial. So the way you might structure this, you might say, here's the normal reward function, you should optimize for this, except if the person says do something else, right, more reward on doing the something else. But if you set this up to be high enough, not that I'm worried that robots would actually figure out how to do this at all, but just theoretically, I want to point out that what we just did is we provided an incentive to the robot to try to get itself in situations where then people would react and give it corrections so that it can then accept them and cash in on all of that reward, right? And similarly, if you make it too low, other things happen. So it's not trivial to tune these things right, even for something as basic as do what people say. Now, I'm not worried about this with robots today. Robots today have very narrow action spaces, so they will never figure out, even if that's the reward function, how to actually do that. Here's a robot. It moves from a start to a goal location. It's trying to be efficient. It's trying to optimize for staying away from things. And it's very easy to get it to do what I want. So if I'm unhappy with how it's doing the task, if, for instance, I think that it's keeping the mug too high up, what I can do is I can just go there and push on it, and it will do the thing. And I can write a controller pretty easily, maybe an impedance controller, that makes the robot actually compliant to human touch. The interesting thing for the robot, though, and what's hard for a real robot today, is not so much accepting this kind of oversight, but figuring out what to do with it afterwards. Because the moment I let go, right, the robot goes back to optimizing its objective, its reward function. And so the moment I let go, right, the robot goes back to the old way of doing the task. And I keep pushing on it, and it keeps going back, and I keep pushing on it, and it keeps going back to what it thinks is the optimal way of doing it. And it can be very frustrating. So with real robots, I think the more sort of near-term problem is that you shouldn't just be compliant, you should actually try to continually learn from this oversight that people give you and try to not make the same mistakes again and again and again. And so what all these three examples, I think, teach us is that the classical AI picture here is missing something. There's no reward function that's exogenously specified. It doesn't come from the sky. Instead, what we have is we have people that want things internally. And that's what the robot should be trying to optimize for. If it's a designer, right, then the designer might actually specify a reward function. But chances are, because we're human and because we're fallible, that that's not necessarily going to match up perfectly. It's not going to be totally wrong, but it's not going to match up perfectly to what the designer actually wants internally. And what we do right now is we just take that for granted. We just plug it in and say, this is what we're optimizing for, as if humans are perfect, but they're not. And I think the picture that we should really be reasoning about is this one, where you have a robot that tries to actually work with the person to figure out what it is that they really want. And it's hard because we can't actually decode what people think internally. It's a really tough thing to do, but I think we can make some progress towards that. So let me give you an example of one thing that we've been thinking about. So we're back to the boat racing game. Do you remember the game with the boat racing that was doing the loop? So what was happening there was essentially the boat had the choice between winning and getting a lot of points, say 20, or exploiting this kind of loop that it could do, get even more points, but not win. And it chose the second version. And the reason it chose the second version was because there was a designer who said, look, you should optimize for score in the game. So the interesting question is, why did the designer say that, right? We designers are not totally dumb, right? We're not just going to write down a reward function and send the robot off into the world and hope for the best. So the reason was that the designer actually tested this robot on some environments. And on those environments, optimizing for points got the boat to actually do the correct thing. So at training time, the environments that the person actually looked at were pretty different than this one test environment. At training time, you could actually win with a lot of points. If you had fewer points, then you wouldn't win as much or as many times, or you would lose. And so score and winning were correlated at training time, but they were no longer correlated at test time. And that's what broke things. So that's one of the things that can go wrong, where you have features that no longer correlate. Things can go wrong in many other ways. Here's another example. Say I'm building a robot to drive around the CMU campus, and I know it's going to have to deal with terrain, and it deals with grass and paved roads and dirt roads and so on. And maybe I want the robot to avoid the grass and protect it. So I have to write down a reward function for that. The robot doesn't actually know what's grass and what's dirt and so on. And so all it has is some sensor input, let's say LiDAR camera images. And so the first thing I'll do is I'll write down some classifiers, some detectors for these terrain types, and then I'll define my reward function that says, grass is bad, going on dirt or pavement is better. And so I deploy the robot after some testing. And it does well in CMU. I send it to Berkeley, it does well in Berkeley. And then, I don't know, I send it to Hawaii. And in Hawaii, right, there's grass, there's dirt, but there's maybe some dangerous surfaces as well that I don't want the robot to go over. For dramatic effect in this talk, we'll refer to these as lava, right? There's mountains of lava. Now, what the robot will do at deployment time is it's going to use its reward function that I defined to evaluate the different surfaces. And who knows what it's going to do for lava. That wasn't right. We don't have detectors for that. We totally forgot about it. So this is one thing that another thing that can go wrong, which is maybe we don't actually think of all the edge cases, of all the possible things that our robots might have to face, like dangerous surfaces that don't appear at training time, but appear at test time. So even though with the boat example and this navigation example, there are different things that are going wrong, they have one important thing in common, which is what gives me hope. And that one thing that they have in common is that the designer actually did a pretty good job for the training environments. In other words, there's not much that we know about the true reward, what the person actually wants. But there's one thing that we know, which is that whatever reward function the person specified, it might not work always, it might not produce the right behavior always, but on the training environments, it produces the right behavior. And that's information that we now have about the true reward, right? We don't have the true reward, but we know this much. And in fact, I'd argue that's all that we should assume if a person specifies a reward. Another way of saying the same thing is that, look, what we end up specifying is contextualized in the experiences that we have. Robots should not interpret it literally, right? Should interpret it as being contextualized in the experiences that we have. For roboticists and DIOTIS mathematically, the way we do this is instead of just optimizing the reward function, we treat it as an observation in the Bayesian sense about the underlying true reward. And to do that, we have to reason about if theta star is the true reward. If the person is looking at the training environment, what will they write down? What is likely for them to specify? And that's where we use our insight. What we do is we say, well, how likely is theta tilde to be written down as the specified reward? Well, I have to look at what behavior it incentivizes on the training environments. And if that behavior is good with respect to theta star, then I know that if theta star is the correct reward, theta tilde is likely to be written down, more likely to be written down by the designer as the specified reward. So that's how we do it. Intuitively, what this means is as follows. Going back to the boat example, imagine that there's a plethora of different reward functions that the person might define, right? So there's all these different features that might be relevant. The person specified theta 2, which is maximize score. That's what they picked. Instead of just optimizing for score, what our robot is going to do is it's going to take a step back and say, what's the experience that they had to draw on when they specified theta 2? Let's take a look, right? They looked at these environments where you could either win with a lot of points or lose with fewer points. And theta 2 incentivizes the behavior where you get a lot of score and you also win. And so what the robot is wondering now is, for which of all these possibilities is winning with high score a good idea? Which of these reward functions could have been the true reward function? And what you can figure out pretty easily is that maximizing score likes this behavior. Minimizing score, or trying to lose, if that were the objective, that doesn't like this behavior, so you can throw that right out. But you also understand that maximizing winning is something that likes this behavior. So now the robot knows, okay, I was told to optimize for score. I'm pretty sure the person didn't mean to lose or to minimize score, but I don't know if they didn't mean to win. Because based on the information that they had, winning also might look like a good thing. So, and they might have not gotten that. So this is a very simple toy example. We've been playing with situations that are actually complicated, where the robot doesn't get convenient access to all the important relevant features like winning. We've been looking at motion planning too, where we end up with these more robust behaviors and these complicated new environments that the robot is choosing. And so overall, I think that was just one example of the approaches we can take. But overall, what I'd say is, whether it's a designer that's writing down a reward function, or an end user telling you that you're doing something wrong, or even actually giving you corrections, what the robot should be doing is taking all of this in as useful evidence, as useful information about what people actually want and what the robot is actually supposed to do, and improving that over time and getting better and better at optimizing not a specified reward, but what people actually want. Here's what happens with our little example. When you do this, I push on the robot, and instead of just going back, the robot interprets that as evidence about what I want, and it ends up doing the task very differently. So to conclude, there's this mismatch that we now have, and I think both making robots more trustworthy in the ways that we've talked about, as well as making robots more transparent, is going to help with not necessarily resolving one thing or another, but bringing these two items, the real robot and the mental model, closer to each other and have a common middle ground that works out well for the human and the robot. With that, I'd like to thank you very much.
Thank you so much. You won't need the mic. So that was really wonderful, and I think especially the ways in which you focused on reward functions as connected directly into the end of the previous panel, this idea that we want the robots to support our goals and our interests. Well, then we have to say what counts as success. Mm-hmm. And how do we do that? Well, that might be very hard for us humans to do. And so how can the robot learn what we wanted without us even knowing it? Mm-hmm. But of course, I have to ask that there's a risk. I might say and want the robot to help me not eat lots of chocolate cake, but then it looks at what I actually do and says, boy, you eat a lot of chocolate cake. So how do we help are there ways that the robots might be able to help us overcome our own inabilities to live by what we want?
That's a fantastic question, because I think you're right that there is a risk that what we end up optimizing for and what we want the robot to do are very different. But maybe one way I'd look at this is that our objectives are still there. I still want to be a healthy person. But I'm pretty, let's say, myopic or greedy in my planning horizon, right? So I end up being tempted by the chocolate because I don't necessarily think through in the moment of all the implications this is going to have, or maybe I'm just, there's many ways to which I can be suboptimal in what I'm going for. And so I think one important sort of line of work to take when trying to look at human behavior and sort of back out what our incentives are is to account for the fact that people are not going to be optimal, and so therefore their corrections and their actions are not necessarily going to be what they would if the person were actually truly optimal, perfectly optimal. And what we've been finding is that, for instance, if we assume that the person is myopic, right, then we can do a much better job recovering their true objective function in sort of kind of controlled experiments than if we assume that they weren't. Right, so I think it's important for robots to actually take these biases that we might have, and there are different ones. There's planning fallacy. There's all sorts of different biases that people have. But maybe that's one way to think about it, and that would enable the robot not necessarily to identify whether we want to be healthy or not, but I think the key to what I was talking about is really get the right uncertainty, right? It's not like the robot knows whether winning or score is the right one. It's not like the robot knows that lava's bad, right? It just knows that, given what you've said, there's not enough evidence of either way, and it has uncertainty about those. And there's things that it doesn't have uncertainty about because they don't match up at all. They're not possible hypotheses.
Being able to recognize some of those known unknown. Having something become a known unknown, to use the language from Eric's talk last night. So I wonder, could you also use these same sorts of techniques to handle potential challenges where the robot has to interact with multiple people? So the robot has to learn, interacts with you, interacts with me, and we might have different reward functions where it has to learn what's in common, what's different between us. Would the same kinds of techniques be usable for that challenge?
Good. So one thing that we've experimented with is if the robot can learn from many people, when it sees a new person, it shouldn't start from scratch. right? So for instance, we did this in the context of, say, driving styles, right? So I want the car to customize to how you want to drive, how they want to drive, how they want to drive. And when I see the end person, I don't want to start sort of learning from scratch, because there's common things that all people share, and then there's individual differences. And so one way to think about this is to learn from all of your previous users and build, in a sense, a prior for what you should expect going in, and then let that new person's actions sort of, and take those in as evidence and turn that prior into a posterior.
So it can thereby sort of find what's similar among all of us while still allowing for the fact that people do drive differently or want the robot arm to move differently, the kind of individual customization.
That's right, that's right. But I do want to bring up a related point that I struggle with, which is the car has multiple passengers. Which driving style should I choose? I put a robot in a home, and there's different people who all have different preferences. Which of them, right? What combination? I think all the tools that I was talking about and everything that I've done has been very much along the line of one person, one robot, and the robot is trying to learn the sort of internal objective that the person wants the robot to be optimizing. And I don't know what to do when there's multiple people. I mean, there's simple things you could do, like you could take averages, you could do sort of risk averse, you could do min-max, you could do max-min. There's things like that, but I don't know what the right answer is.
Well, I think in fairness to you, I don't think social scientists know, I don't think political scientists know. I mean, this is sort of the ubiquitous problem in human experience is what do you have when you have conflicting values and conflicting interests.
Yeah.
So I think it's okay if roboticists haven't solved this problem for us yet, but we'll look forward to it in a few years. And I guess speaking of a few years, I'm curious, what do you see as sort of the biggest opportunities for trust AI robotics sort of in this space over the next, let's say, 5 to 10 years?
I think I'm going to go with basically Ila's answer, because I feel like as AI capability advances, and I'm much more pessimistic about the degree of that advance than other people are, but I think we are making progress. I think with that, we get this opportunity to help people be better at the things that they do. So, kind of talking about what we were saying earlier, where people tend to be myopic. Well, one thing that we found is that when the robot is on the same team with you and you're trying to do a task together, if the robot acknowledges that you maybe don't tend to think 10 steps ahead, it can sort of organize the world and take actions in such a way that when you then react to those actions, that reaction is good globally as well. Simple example, because I think what I'm saying is very abstract. It can be as simple as when the robot gives you an object. Okay, take it. Okay, you take it in the most comfortable way for you. Now imagine you had an actual goal, like you had to put it in the dishwasher or something, right? We don't tend to necessarily think ahead to the goal. We do the thing, right? Not always and not for everyone, but especially if we're wrapped up with other things. And one thing that the robot could do is could be reasoning about that and then hand you the thing sort of in a way where it makes sure that the way you then grab it is then conducive to your goal. So you think you still react myopically, but the robot is setting things up such that you're actually better at the task because of its actions. Or another thing is, going back to explainability, it'd be nice, and I think people are doing that, because robots are getting better and better, things like Go and so on and whatever other tasks, better than human capability, it'd be nice if that made us better as well. So a robot could kind of help you make these decisions and say, if you do this, just be careful that 10 moves from now, you might end up here and here's why. And then the person can learn from that and get better.
And so just to conclude the more speculative question, so in, say, 10 years, when we're on, I guess that would be the 6th CMU-K&L Gates conference, how is it going to be different? How do you think things are going to have changed either socially or in this space that we're talking about here?
I guess my prediction would be that we're going to start talking even more about what I might call model misspecification. So that's one thing that I kind of foresee being very worried about because...
So what do you mean by that?
Right, so we talk a lot about trying to figure out what people want. And I worry that oftentimes the space that we're always looking at a kind of a closed world assumption. Here are the possible things. Even if they're defined on sort of raw information, here are the possible things that a person could want. And I just worry that we don't have even observations about things that people care about that influence what they want. And so kind of model misspecification, drawing these inferences over a closed world when we in fact have no way of knowing, basically can lead to issues. Another thing that can lead to issues is just inherent ambiguity, where I really can't figure out based on what you're doing and what you're saying if you want this or that or that. So then I need to be risk averse or conservative, but that's the best I can do. The other thing that I think will change is maybe the hype for AI will die down, and we'll get to focus much more on these very kind of, I don't know, near-term, very practical, ethical issues. And I think this particular conference does a really good job with that, but I've been at kind of other types of events where it's sort of very far out, and everyone's worried that in 10 years, artificial general intelligence will happen. And I think my prediction is that, it won't. And then the hype will be a little more reduced, and we'll be able to talk about real, kind of what Ila was saying, real kind of narrow AI that does something really useful.
Which can both empower and cause challenges for people. So.
That's right.
Well, thank you so much. This was really wonderful.
Thanks.
Good stuff. And this concludes our session on trust. I invite you all to stay and have lunch in the back room. Please feel free to come back up to these tables. It's perfectly fine to have food and beverage here. And we will be starting back up at noon with our session on policy and governance. So, thanks.